Hello everyone. Today I am going to explain about channel couplers in optic fibers, input and output. Myself, Boloju Vasishta from Aerobie section. Coming to the couplers. What are couplers? Coupler is nothing but the joint which is used in optic fibers. Optic fiber connection joints and couplers. Fiber joints. Optical fiber links with any line communication systems have a requirement for both jointing and termination. A single mode fiber has continuous perform length of around 200 kilometers, but such fiber spans cannot be installed. So, what are the fiber joints? In fiber joints, in communication, when we are taking a long fiber optics, we have to keep joints so that we can easily communicate from the requirement system from both jointing and termination. Why we need joints? Fiber can only be installed in lengths up to 2 kilometers. For longer span, a joint is needed for the repair of damaged fiber, for test purpose or thermal equipment. See, the general fiber can only be extended up to 2 kilometers. If you want to make it for 4 kilometers, we have to join the two fibers. So two fibers can be joined by using joints. And for the repairing purpose, from terminal receiver terminal to the transmitter terminal, if there is a break, it can be cleared by the joints. For test purpose at terminal equipments, if we want to test the fiber, without directly installing it, we have to check it by using some part of it. Next, all the fiber cables in building cannot be installed as one continuous cable run. Yes, if we want to install it from one place to another place, we have to cut it and we have to bend it by using joints so that it can be installed from every part of the building. Joints are needed to complete network cabling, and temporary access is needed for test purpose. And for temporarily, if you want to remove it, we cannot remove it easily, so that we are using joints. Fiber pigtail. Fiber optic transmitter and receiver are terminated to be fiber optic pigtail. A fiber pigtail is a short length of optical fiber permanently fixed to the optical source or detector. Manufacturers supply transmitters and receivers with pigtails and connectors. Reduced coupling loss results when source to fiber and fiber to detector. Coupling is done in a controlled manufacturing environment. Fiber joint loss. In fiber connection, the optical loss encountered at interface, the loss is optical power through a connection is defined as loss is equal to 10 into log 10 log pi by po to the base 10. Po is the power emitted from the source fiber. Pi is the power accepted by the connector fiber. So fiber joint loss can be two types: intrinsic coupling loss and extrinsic coupling loss. Intrinsic can be caused by inherent fiber characteristics. Extrinsic can be caused by jointing techniques. There are Fresnel loss, fiber core misalignment, fiber parameter mismatch. Fiber joint loss. Intrinsic coupling losses are limited by reducing fiber mismatches between the connected fibers. This is done by procuring only fibers that meet stringent geometrical and optical specifications. Extrinsic coupling loss are limited by proper connection procedures. Fresnel loss can be identified by using some formulas like R is equal to Na minus Nb by Na plus Nb whole square is equal to minus 10 log 10 1 minus Na minus Nb whole square by Na plus Nb whole square. And the Fresnel types of Fresnel loss can be fiber joint loss or doubling single interface loss. Total loss will be minus 20 into log minus n1 minus n naught whole square by n1 plus n naught whole square to the base 10. So reducing Fresnel loss. To reduce the amount of loss from Fresnel reflection, the air gap can be filled with an index matching gel. The refracted index of the index matching gel should match the refractive index of the fiber core so that it can join the two fiber optics easily. Index matching gel reduces the step change to the refractive index of the fiber interface so that we cannot lose the communication from one place to another place. There are three types of alignments: longitudinal misalignments or end separation, lateral misalignment, angular misalignment. Fiber end phases. In these fiber end phases, it can be curved from the tension. Thank you.